Hello, welcome to Securing the Continuous Integration talk. Thanks for making it here after lunch. And it's always tough to compete with quantum cryptography talks, so I appreciate you all being here. Any non-trivial change in security involves three components, almost inevitably: people, process, and technology. And for people, I only have one piece of advice: hire the right people and treat them right. It's not a new advice, but I've never heard anything better. So that's putting people aside. The rest of the talk will be on process and technology. In securing continuous integration, there are two levels to this game. First, how to make sure that the continuous integration doesn't harm your security, that it doesn't serve the weakest link in your overall organizational architecture. And step two, only after that, only after we know it does no harm, we can start looking how to utilize this neat continuous integration process to actually improve the security of the software that we are developing. So that's the plan. I said process and technology, but this is not tools talk. The choice is enormous in this space. I'm not going to say this is the recommended tool chain. It's not on my agenda. Enormous choice. It's what I want you to take out of it is when you're choosing tools that are right for your circumstances, for your CI pipeline, how to evaluate them, what to look for, what features to look for that will allow you to use them securely and put them together securely in such a way that these tools are not the weakest link and not the wide open gate into your organization. And then my secondary goal, after I have this pipeline going on and it does what it says on the tin, at least, how I can use it to improve my software security. So basic continuous integration cycle, yes, I know everyone knows, but when I talk about components and call them specific names, at least we are all on the same page what I'm talking about. So we have developer who writes code plus tests on a dedicated development machine. Plus test is important. It's almost impossible to have continuous integration if you don't protect your freshly written or modified code with tests. Then pulls latest from version control repository. This step to run local build and test is optional but very popular. And the talk before lunch, Joseph mentioned that there are now tools that let you do all sorts of things, security checks on developer machine, even before it's committed. So if you have these tools, this is the step in which you will utilize them. Then commit to the version control repository. And then we have CI servers that continuously pulls the repo for commits, detects a new commit, runs the build, runs whatever extra tests you've configured in your pipeline, generates feedback to some kind of dashboard or gadget. Developer observes the feedback. If everything is fine, congratulate yourself, move on to the next feature. If not, rework, change, commit again, repeat. So this is a basic cycle, just to be sure that when I'm saying things like repo separate from the server, we all know what I'm talking about. The first rule of securing continuous integration: what happens in dev stays in dev. Isolate your environment, whether people are working on physical machines, whether they're working on virtual machines, it all must be segregated from your main corporate environment. And the reasons are twofold. First, corp can harm dev. Corporate can harm dev. If I am reading my corporate emails on the same machine I'm doing my development, and I clicked on a phishing link somehow, I have now Keylogger installed, and attackers can steal source code or make something more interesting, entice me to commit an attacker-controlled change list, which, if not detected further in the pipeline, will result in the backdoor being deployed. So corporate can harm dev. In the other direction, dev can harm corporate. If I'm doing some kind of network intensive test, stress test, and it's not isolated, I can influence other departments of my organization, and the worst case, of course, financial, before end of financial year. So segregate your development environment from your main corporate environment. More difficult to achieve if people can work remotely. More difficult to achieve if an organization has policy, bring your own device. I'm not saying it's impossible. I'm not saying you have to forbid these policies if you want secure continuous integration. I'm just saying it's more challenging and you need to be there. Next piece, version control server. It has one job only, right? To contain your source code. So harden this server, remove, disable anything else that would normally run on it. Seems pretty obvious to say that each developer should have individual account, but I have seen people going with generic shared accounts. Clearly, it's not a good idea. You lose any ability to attribute the changes, to do any kind of audit. Individual account. What kind of account? Single sign-on is better than dedicated account for individual tool. But realistically, we are probably never going to achieve this, that all of the tools in my pipeline are single sign-on account. There will always be this tool that's perfect for you in every other way, but it needs a dedicated account. So make sure you have a business process to close these accounts when they're not required anymore. And you must keep it up to date when you add more tools. The process needs to be updated. What are the features to look for? You should prefer tools that allow you to have role-based account control. Then you can have granularity and use this granularity to configure access to repository on a need-to-know basis, but don't go crazy, like in such a way that doesn't interfere with developers' productivity. Next piece is the main workhorse of this whole thing, integration build server. First of all, it needs read-only access to the version control. Don't give it write access to version control. Then, who's responsible for keeping it up to date? Main corporate IT is always happy to say, you are exempt from my policies, it's your own problem. And developers like to develop, they don't like to be IT administrators. And what very often happens, this server runs out of date with OS patches, it runs out of date with whatever software is installed on it. And of course, it's right for an attacker to make use of its out-of-date software. So you may be exempt from your overall security policies. You need to take responsibility within development department to keep it fully patched. External components that you pull at build time from public repositories. How do you know that repository wasn't compromised? And how do you know you're not taking something malicious into your build? Consider setting local repository. It gives you much more control. It also makes build faster, even if you don't care so much about security. There are other benefits. What actually runs on this build server, with what options we run our compiler and linker? Check vendor advice for security and pick the most secure options that are recommended. And make it standard. If possible, make sure that developers, when they run their local builds, use the same options. It stops you chasing forever. It was different on my machine. So standardize the most secure options and make sure they apply everywhere. The last bit is interesting feedback mechanism. who else is listening to a feedback mechanism? Unless it's a very, very low-tech mechanism, like I have this in all the developers in the same room, they look at some kind of physical dashboard and they feel like it. If it's not on that level, you need to think about the security of this mechanism. If you follow the news on Internet of Things, you know that these gadgets are very, very insecure. They're subject to information disclosure. Sometimes an attacker can control their status as well, so there is an integrity problem. When you use toys, which is much more fun than just carrying an object that says broken bill, make sure they're secure. Custom integration scripts, all these tools, how they're held together. Very often in job description for DevSecOps, you will see the expression glue skills, which is great to have on your team. That's unselfish people who are prepared to write scripts that utilize tool APIs and put them all together to make sure it's not just a box of individual tools, but really a pipeline. But are you cutting corners when you're writing these scripts? Some of those require punching holes in the firewalls. Sometimes people would hard code passwords in these scripts. Even if the script itself is not dangerous, the pattern I often see, it would be script with 4 writable permissions, and then it runs as a privileged account. So if an attacker finds a way to modify this script to add system commands to this script, that's an instant escalation of privilege on your build server in your continuous integration environment. So I'm not attacking a particular tool. Literally, I went to Google, I searched broken build plus gadgets, and that was the first example I found. So I'm not attacking this tool specifically, but it has everything. It says, open a non-standard UDP port, please. Will be very handy if I'm already on the machine, but I need to exfiltrate data. It says, embed your passwords here. So literally, the first example has everything. So glue skills are very important to have in the team, but solvent abuse can kill. Be careful when you exercise these glue skills. These scripts need to be treated as first-class citizens. Put them under source control, do a code review on them. They need to be subject to the same level of scrutiny as your production code, because they're just as dangerous, if not more so. Continuous integrations are rarely planned upfront. They grow organically as teams mature and add more tools. Don't acquire tools by accident. Sometimes people only learn what they have during some kind of audit, which is way too late. I'm not saying you need to introduce really heavyweight secure systems lifecycle, but even if you have very informal product choice and evaluation assessment, it can be quick, but it needs to be conscious. Just picking the first tool on Google search that is free is not enough of security scrutiny. I'm going back to account management. Ensure that it covers all of your tools. And when you add tools, don't forget to adapt the process. I'm not saying treat everyone who leaves your team as a potential criminal. No. Even if people are completely ethical, they leave these unused accounts behind. It's just increased attack surface. The more dormant accounts you have, the more chances are that an attacker will brute force or guess the password. So, dormant today, active tomorrow, and you have no time to prepare. Now we are to the level 2 of this game, assuming I put it together in such a way that doesn't harm security of my organization. How I can use it to actually improve the security of the software that I am developing. I hope you can see something on this slide. If not, there is a white paper that I've released today, and it covers all of those in way more detail. What it is a maturity model for introducing security into your continuous integration. And top 4 rows I borrowed from as a popular maturity matrices for continuous integration, but the dedicated security row is based on our own experience with a variety of clients, what they're doing for security, how mature we think they are, and what they're doing in their continuous integration pipeline. And of course, won't have time to go through all of them, but what I want you to take out of it, in software development, there is no understanding that security features are not enough for secure product. Like, it's not enough to have good authentication and access control. All of the features are attack surface, and all of them must be secure before we can have secure product. So for this matrix, like, it's not enough to do these activities. That's actually level 2. Before you can start tackling security role, you need to look at everything else, how secure all those cells are. Because all the tools that we throw there, all the processes that we set up there, they can increase our attack surface and be used by an attacker. So let's look at a couple of these practices. The first one, we often get asked, manual code reviews, aren't they a waste of time in continuous integration? Our goal is to automate everything. Manual code reviews, should we aim to get rid of them? And my answer is, they're not a waste of time if they're done correctly. So automate all the donkey work. People shouldn't waste time arguing about coding conventions and all the checks that can be automated. Automate as much as possible and leave people to do it on a level that tools cannot touch. Maybe look at design level. Maybe if they've done threat modeling during design, then during code reviews, they can validate that implementation doesn't break the assumptions we've done at design stage. So stupid work to tools, leave people to do smart code reviews. If you bother to have manual code review policy, then don't have rules that say we only need to review risky changes. You don't know if something is risky until after you've reviewed it, so just review everything. Don't have it as a separate task on your task board, because then there is a temptation under time pressure not to do it. Or another way to waste time is to say, I will save them up, I will save code reviews from separate tasks or stories, I will do them end of week or end of iteration, which is waste of time. It misses on the main benefit of this code review, which is quick feedback. So don't have it as a separate task, make it a definition of done for every task. And another observation, if your decision tree looks like that, then why are you wasting time making this decision? Decision that has only one outcome is a waste of time. Reject and rework is part of normal. It shouldn't lead to people falling out with each other. It should be part of normal, and it needs to be defined. What do I do after it was rejected? Do I go to the same reviewer, or do I just submit it again, fix it up? It needs to be defined part of your code review process. Don't have decision tree with just one outcome. Eliminates the decision completely. Another basic beginner's practice that I recommend introducing is root cause analysis on externally reported issues. People like to rush into bug bounty programs because it sounds sexy and all the best people do them. But actually, are you ready for that? And this one says, don't trouble until trouble troubles you. When you have externally reported issue, can you do anything useful with it? Can you use it to improve your continuous integration process? Either ethical researcher done a responsible disclosure to you, or maybe you were proactive and you ordered an external pen test. What is the outcome? Like, you received this report from pen test, you received responsible disclosure. What will you do with it? You should use it to go through your continuous integration process and think, what was missing in it? What check, what tool would have caught this issue before it was released externally? and use it to improve your process continuously. And then after a while, maybe you will be ready for that bounty program, but not before you know that this process is actually useful in your organization and is used to continuously improve your CI process. The last one I want to look at is chain of custody. How do you know that your release notes contain the truth, the whole truth, and nothing but the truth? What you trust in your release notes based on? If you don't derive them directly from artifacts, if you compose them manually or separately, this is the gap where discrepancy can come in. Whether you release every change individually in continuous deployment, or whether you batch them and release on some kind of separate cadence, this is what you need to ask. Can I trust my release notes? It's not only important for security in the most direct sense. Did I have a backdoor that someone put in? It's also important for your incident response. If you don't have an easy way to match your changes to your release numbers and the build numbers, you will have a very painful time during incident response. This chain of custody covers, has every unit of work gone through all the checks I've planned, and do I have time of check, time of use issue? Maybe I've done all the checks, but was the component modified since I've checked it before it made into release? So this matrix is not meant to limit you, it's meant to guide you. Maybe in your circumstances, it makes sense to do something advanced before you've done all the intermediates. So don't treat it as a straitjacket. So main trigger in continuous integration is on commit. And gradually, as you mature your pipeline, you will add more and more to this trigger. Don't throw everything at the dev team at the same time. And also, some of these tools have steep learning curve. Sometimes management expects, I gave people static analyzer, their productivity, their velocity should go up starting tomorrow. No, actually it may even go down because it will take time to learn, to configure it, to eliminate false positives. So don't do everything at the same time. Have some kind of reasonable path to maturity. As I said, no two journeys are the same. You will have to evaluate what makes sense. And when you pick tools, pay attention to what features are in these tools that will enable you to integrate them securely. Whatever integration scripts you have, they need to be first-class citizens. And gradually, you will do more and more things to influence the security of the software as well. So this is the white paper. It covers this material, obviously, in much more details. So if you have questions after reading it, or if you want more details, you can find me by email or on Twitter. And if there is time for some questions on the spot, now is the time? No? Okay. So thank you for attending.